class, actually. You would take 3 and kill a variable, and then you have to take several and kill another variable. You have to do kind of like the same thing. Yeah, it's a lot. All right. So no questions from homework? Okay. I'm an optimistic fool, so I'm going to assume that means it's all good. I'm not getting a ton of homework in, but hopefully that's not for bad reasons. So let's see. We're getting into section 7.5 then. Let's do a couple just to make sure we're all on the same track from 7.4. So let's see. How do I solve this thing here? How do I simplify this? 7.6, we'll get into equations that look like this. So then we'll be solving. There's no equation, so I can simplify it.
Factor.
Good. So you always want to factor first so you can see what you're working with. All right. Okay. Show me what you're working with. So you got, how's that guy factor there? And the beautiful thing about these problems is you always have a hint. Right, so I bet you anything, this is one of them. So x plus 8, x minus 2, makes negative 16, big one's positive, kick ass. Right? So then, who's missing something? First dude, what's he missing?
X plus 8.
X plus 8. So then you give him what is missing. Oh, you're dead. So on one level, I want this to you realize that solving seems too easy. You just got to say, okay, who's missing? Let me give it to you, and then you're almost done with the problem. Right? The rest of it's really cleanup. So now I get 2 plus 16. Now I got to be careful about something here. Minus 7. Minus this, minus that. This is minus this whole thing, right? People always mess it up, but you could always do this for yourself, plus negative 1 in front of that. And you got to subtract that whole thing, so they both get a negative sign. Okay? And on the bottom, I've got still my x plus 8, x minus 2, and then you just put like terms together. So this is cleanup stage. Yeah, once the denominators are the same, we know this. We know how to do fractions. I know many of us have that as a weakness, our fractions, but we know the basic idea. They need a common denominator before we put them together. And the easiest way to make the common denominator is give them each what they're missing. That's going to make them, in the end, the same. Right? So when you clean up the top, what do you get? 9. All right, 9 minus 2x over stuff. Is that going to go any further? Can you factor the top? There's no way that there's something on the bottom that's also on the top. There's just no way. So I know I'm done. That's it. Yeah.
Did you work for the 2x plus 16 minus 4? Is that from where is that?
Yeah, 2x plus 16.
Oh, okay.
Minus 4, minus 7.
That,
Yeah.
okay.
Cool. So now I can just put the tops combined over the common bottom.
Yeah, and then
keep going. Cool. Lock it. Yes, sir.
Why we cannot factor the 9 minus 2x?
Yeah.
3, I mean,
2 can't go in.
Yeah, there's no GCF. It's not x squared, so I can't try like squares or something. If it was 9 minus x squared, then we could factor it. But even then, there wouldn't be any pieces that were the same as the bottom. There would be no reason.
so if there isn't anything,
Then you can stop. Yeah. It's just like if you get to the 3/17. Do you have to keep going? If you got 3/17 as an answer to a problem, no, I can stop because it's not going to, nothing's going to reduce. Yeah, so it's exactly the same there. There's just nothing that's going to be the same on the top and bottom. I can stop. Okay, cool. Maybe. All right. Okay. Maybe it's just me. Maybe I'm just overly sensitive this semester, but I always feel like some of you guys want to beat me up. You're like, is that what it is? All right, good. I'll take it as a good thing when I see that then. Oh, you're retaining information? No, I want to beat you. Oh, okay, shit. I can't tell. I cannot tell the difference. So the only place you got to be a little careful, and they don't get overly disgusting in here, but one little place you got to be careful is something like this. If I had, let's see. Yeah, let's make it this here instead. Sorry. Make that a minus x there. My bad. I want something specific to happen. So, of course, the first step, no matter what's going on there, is to do what? I always have somebody that, I understand your desire to turn this around, but you just can't. 9 is positive, so the 2 3's that come from it have to be positive. So you pretty much take it the way it is given to you. So 9 minus x squared would be... Plus x. Yeah, it's a good old difference of squares, right? What do you call a thank God problem? Or a thank your favorite deity problem, right? And then this guy here would be...
X minus 3x plus 2.
Good. Some of you guys might see why I had to switch that sign. Maybe. Do they have anything in common?
No. Yeah.
They do. They do. We just haven't uncovered it yet. Something is almost like x minus 3. So please, dear God, don't give this whole thing to him and this whole thing to him. Right? What is this? If I take a negative out. Yeah, so they have an x minus 3 in common, right? It's just this guy has an extra negative there, right?
And what do you do with the extra negative?
You can bring it up top. It's kind of nice. So sort of like if I had 2 over negative 3, what's a better way to write that? Negative 2/3. I can move that negative up top. You stop right there for a second.
Bring the negative up.
Definitely. What's 3 divided by negative 1? Negative 3. So, that's really what I'm doing mathematically. Or I can just look at it like I'm bringing the negative up top. So now I have negative 3 over x minus 3, 3 plus x. So that negative came out of him and went up there. And here I have 2 over x minus 3. So the one thing you got to be careful about, a few problems are going to have that reversed.
Yeah.
You just got to recognize that if you take a negative out, it's the same damn thing. Otherwise, you're going to get these huge, you're going to give this whole thing to him, this whole thing to him, you're going to have all these terms, it's going to be insane. Don't do that to yourself. Then he complained to me about it. I'm like, I didn't assign you that hard of a problem. You made it that hard. So what's he missing?
X plus 2. So you took x minus 3 and x plus 2, and you took that negative out. And
Not here. This is fine. I left him alone. I took a negative out of him so that it would look the same as that guy. And that negative I put up top. So now I can just focus on the bottom. This is common to both. He needs x plus 2.
now that makes sense.
And he needs
3 plus x.
3 plus x.
Oh, which would be the top and the bottom.
Exactly. We know that. So we know all of this. We've got to realize these are just fractions. But you at least are okay with the fact that if I have 1/3, I can make that become 2 over 6.
Yeah.
Because I know I'm allowed to multiply top and bottom by the same thing. I can't just multiply the bottom by something and leave the top alone, or else it's a whole different fraction. Yeah.
So basically in this, whatever's left out, like you pretty much got it to where it needed to be, but because that one has one different and that one, you basically times it by it. So
Yeah,
it's the same
give each
cost.
other what the other guy's got that they're missing, and
Yeah.
they end up at the same place.
Yeah. Okay.
Right? That's why I like the idea of the little kids running around. He's got more ice cream. Well, here's some more ice cream for you. Now you got the same thing. Now get away from me. So he's got x plus 2. Here you go. He's got x plus 3. Okay, there you go. Screw it. We both got the same thing now. What can I do? Yeah, so negative 3x minus 6 plus 6 plus 2x over as plus 2 as minus 3 6. And then just clean up, continue the cleanup. Right? Once you get the denominators the same, it's basically cleanup after that. Yes?
Is that the reason why you put the 3 before the x's, the 3 minus x and 3 plus 6 is because of
Yeah, I mean, at the very beginning, I could have turned this around. 3 plus x is the same thing as x plus 3.
Just the minus.
Right? Yeah, I just can't turn this around. 3 minus 1 is not the same thing as 1 minus 3. So addition and multiplication, I don't care what order I do it in. 8 times 4 is the same as 4 times 8. But 8 divided by 4 is not the same thing as 4 divided by 8, right? So multiplication and addition, I can turn them around all day. Subtraction and division, nope. Right? Or else I'm going to change it totally. But so I could have made this x plus 3. I just didn't. Nobody suggested it till now. We're already done. But I could turn it around. Cool. So what do I got on the top? What happens on the top? Yeah, these go away. So I get negative x over that. I'm tired.
What's that last term? You have x plus 2.
Yeah, just all the same stuff. 3 plus x. Yeah.
There's no particular order that the bottom needs to be in. There.
No, again, because I can multiply whatever we want. Yeah. Just don't multiply that back out. That's extra work that's unnecessary. Right? Because the last thing you want to do is to make sure nothing cancels, and you can only do that if everything's factored still. So don't multiply stuff back out on the bottom. Okay. So we're going to get into 7.5 and 7.6. And let me show you something. Just wait. That's your job, dude. Show us. So if I had, if I have a fraction 3 over 6, so I can make that 1/2. Yeah. Right. Who knows what to do if I had like 0.1 over 0.4? What could you do to the top and bottom? Why is that bad? Multiply by 10. Good. So, so there's kind of extensions to this idea of reducing. I don't just have to divide. Sometimes I have to multiply to make my numbers whole. So 0.1 is not a whole number. In fact, what is 0.1 as a fraction? So another way to write this would be 1/10 over 4/10. So I can multiply top and bottom by 10 because that would cancel those and I'll get 1/4. Whole different way to look at it. How you guys doing?
Good.
And why? So obviously if I write it so if I have 3/5 divided by 7/10. Right? We desperately want to either run away from the thing or do something to make it look better. Why does it look ugly? There's a fraction of a fraction, right? So we don't like that. So the nice thing is, I want you to realize you can only kill fractions if you have two sides. Like in an equation, I can multiply both sides by something and it can kill the fractions, right? We've done that before. To solve equations where it was over 7 over 4, I can multiply by 28 and kill it. This has got two sides. It's got a top side and a bottom side, right? Mm-hmm. So I'm completely allowed to do like we just did here. I can multiply by the LCD, because that's what will kill my fractions. So what would the LCD be? 10. So if I multiply by 10,
6 over 10.
yeah, 5 goes into 10 twice. So the top is 6 over 7. Now it looks much better than 3/5 over 7/10, right?
I don't think I understood that.
Were you cool with this? So you have to be cool with this.
Yeah, but the way that you crossed them out and got 6 sides, I don't understand.
So on the top, if I just focus on the top, let me do this again. So if I have 3/5 over 7/10. So I multiply by 10 because that's the LCD. I'm going to show you a slightly different way, but same way to do this. On the bottom, let's focus on the bottom. What happens on the bottom? The 10s cancel. It's 7. On the top, what happens? If you want to, you can put that over. 5 goes into 10 twice. 2 times 3, 6. There's a slightly different, but really the same way to do this. It's kind of related to the way I teach how to solve equations with fractions in them. Same problem. If I first focus on making them both have the same bottom, what does this guy need? We'll have to multiply him times 2. So now it's 6/10 over 7/10. And I don't know, see, this is the same math, but maybe this is better. So when I multiply by 10, there's no guessing about it. I just directly die, and I get 6 over 7. Just a little more directly, maybe. Right? Whichever way you like better. But it's the fact that I have two sides that allows me to do this. If I just have 6, 7 sitting there, I can't go, I don't like that. Let me multiply by 7. There's nothing to balance it out, right? So when people start to learn that you can kill fractions, you try to kill all of them. That's no good. Doesn't work. Don't do it. Here's a third way to do this. Holy crap. Here's a third way to do this. So if I had 3/5 divided by 7/10. Well, how do you divide fractions? This is 3/5 divided by 7/10. This is 3/5 times 10/7. Yeah, 5 goes into 10 twice. 6/7. Cool. Okay, cool. So for that problem, that was easy. But let me show you why.
Yeah, I was going to say, when you add all of the extra
Yes,
stuff in there,
yes.
then it will get...
They're not all going to be that easy.
Yeah.
So let's see. Let's do kind of the next level of thing here. So what if I had let's see what I got, Jeff. That should get that.
You could at least make
Like
one
X
of
squared or
them.
X Y?
XY.
X Y.
Yeah. Otherwise, it'd be 2/4 would be 1/2.
You first have to do the subtraction and division.
You could. That's one way to do this.
Could you split it out and make each section that you're dividing by its own, the denominator the same? So like one has X and the other one has XY. Could you make that one with a Y?
Of course you can.
Up top.
Of course you can. Totally. Totally. So let me show you a very direct way to do this. So we're going to do this one several different ways also. Let me see if some of you guys like this way, and if you don't like this way, I'll show you another way, kind of based on what you're saying. And we'll see whichever way you like better is the way you should do it. Right? So math is not about, so the way I try to teach is show you a few different ways to do things. It's almost bad if you have too many ways to do something, because then you get a little paralyzed. But what's the LCD for everything?
X squared, Y squared.
X squared, Y squared. Because that would cover everybody, right? Okay, now, here's the most direct way to do this. And then we'll kind of step back and step back. The most direct way to do this is to multiply everything by X squared, Y squared.
But you don't have to multiply with.
Not many people say anything about my handwriting is anywhere near perfect, but it's the color, right?
No, I'm saying like the way that it looks, like how the drawing is. I was thinking it was going to be all over the place.
Oh, okay. All right. So all right, so here we go. So if you don't like this method, just kind of wait, and I'll show you another method. Some of you guys are already like, I'm going to wait. And then you're going to realize, oh, it doesn't get much better. If I multiply this by this, what's going to happen? One of the x's is going to cancel. So I have 3xy squared, because that x cancels with that x, and then it picks everything else up. Who's still with it? A few of you guys. Okay, great. Yeah, the rest of you just hang on. What's going to happen here?
2x.
Yeah. How many x's cancel? How many y's cancel? One of each. So the 2 has one of each left over, doesn't it? Okay, some of you guys see what I'm doing. Great.
Yes.
If you don't worry. It's not any better or worse than another method. But I want to start with this one because it's the most direct way to do this. If you don't like this one, no worries. I just had to pick one to do second. And I just happened to pick the second one to do second.
Can you just explain that process one more time?
So x squared y squared times this, because I got to distribute this, right? So if I put an x squared y squared next to this, 1x would cancel. And so it's 3 times x y squared.
Okay.
So you can actually, if you want to, you can write it next to each one. So here, 1x and 1y would cancel, wouldn't it? So then you get 2xy. What happens here?
X, Y, cancel.
A y squared cancels.
Y.
So you're left with 4x squared. And here, x squared cancels, so you're left with 2y squared. Can you factor the bottom? Can you?
Yes.
You could take a 2 out, but does that really do anything for you? No. So you know you're done. Okay, now let's try it a different way. For those of you who didn't like this way, and you made your position well known. Looks like shit. What? I don't see shit. Oh man. This semester is a weird one. So, had somebody come up to me and said, Professor Waller, I hate your class. I'm like, well, that's a stupid way to start a conversation with your teacher.
Didn't you just say that?
No, I'm like,
What did you say back?
I said that. I said that's a really stupid way to start a conversation. And it's just, he doesn't even, anyway. You got a lot of people whose mental age doesn't quite match their physical age. But that's how guys are.
That's the same one.
It's the same one.
Yeah.
I know. It's the same one. Here's a different method. I like that. So another way to do this, like some of you guys were suggesting, I could just focus on the top like its own problem. So what does this guy need? Y. And now, and look at the bottom. Let's see if we can handle the bottom at the same time. What does he need? X squared. And he needs
Y
y squared. So on the top I get.
You need an X and Y.
Okay.
3y minus 2 over xy.
Yeah, what's the matter, guys? You alright? Yeah. So the top is its own thing. Top is its own thing. This is the suggestion I heard, and this is a fine method to do. So you get 3y minus 2 over xy over this problem.
4x squared plus 2y squared over x squared y squared. The original is x.
What's the matter? If I gave you that problem by itself, you should have been able to do that no problem, right? You can see very easily that guy's missing a y, not a big deal. Right? So just look at these two as two separate problems.
He's not adding the y, he's multiplying stuff.
Yeah, I have to multiply this guy to make it the same as this.
Oh.
Yes?
Does that say 3y minus 2 over xy?
Yeah, 3y minus 2 over xy. That's what this says. Oh yeah, sure. Okay, and then we could do like we did earlier and say this is 3y minus 2 over xy divided by this. So it's 3y minus 2 over xy times...
No, really. The first one was
Yeah.
no.
First it was a...
Who said not really? Oh, Jeff, no, not really.
And from there you just factor.
No. Don't overthink it. This is multiplying, right? So what cancels? Doesn't an x cancel there?
Yeah.
And a y cancels there. So now you can distribute xy through here, right?
Yeah, the other way is a y.
Yeah, way easier.
Yeah,
That's what I thought. You guys don't believe me. Alright, this is a little bit longer, but then again, at the same time, it might be a little bit easier for some of us. So if you like this way better, that's awesome. It's sort of like me asking you if you like, a food. You're not a bad person if you don't like corn. Which is good, because I don't like corn. So. What? I love it. Alright. So cool. So you pick one of those two. There are a couple other variations, but they're basic, just slight variations on one of these two main methods to do this. Alright. So let's try another one. You guys try this one. Whatever method you want to do this one here. Yeah, you get the 3x, y times y is y squared, minus 2xy, 2 times xy. Right, just distribute that xy to each over 4x squared plus 2y squared. That's what we got earlier. Same thing we got earlier, yeah. Yeah, that's why I don't like that way too much. Gotta keep track of extra stuff. What's the LCD? Yes. 6. LCD between 6 and 3 is 6, and you need an x, so multiply that by 6. Yep, that's what will cover everybody. If you want. Sure. Yeah, that's fine. Yeah. What's up? So if you want to, but you have to make them, are you trying to add these? You have to make them LCD, right? You give him an X and give him a 3. If you want to, that's one way to do this. So I'm not sure which way you're trying to do it. You got to multiply by the LCD. What's the LCD of everything? Between 3 and 6, what's the LCD? 6, and then you need an X. So 6x, you multiply top and bottom by 6x. You have to multiply top and bottom by the same thing to be legal. So the LCD of all the fractions at once is 6x. So I got to multiply by 6x to kill these. Whatever I multiply the top by, I got to multiply the bottom by. So we're multiplying this by 6x. Yes, because the x's will cancel. So it's not like that. If you want to, you can do that way. If you want to. The first way would be no bars here. Yeah. Well, good.
You are going to do that, so
Square.
you're going to have to do 6x. So that's the end of the minus the end of the 6.
Yep. Good.
Yeah, you have to put this cancels out.
2x, because the x is going to cancel for the first one, right? Yep, plus 6. We got the bottom, you put it on the top here. So x times x, because the 6 is canceled, right? So x times x is, they're across from each other, they're not up and down. The 6 is canceled because one's up, one's down. The x's are across from each other, you multiply them. You can only cancel if one's on the top, one's on the bottom.
Can you reduce?
Reduce what?
Like the 26, like factor that you do?
No, because they're both on the top, right? Isn't this 6x over 1? So they're both the pieces on the top, so that comes in 18. Multiply, yeah. So, one little modification we picked up on the way. If I multiply both of these, what's the LCD of everybody?
6x.
Good. And the way you can do that is look at your numbers. You know it's a 6. And you also need all your variables and then just x. So you only multiply top and bottom by 6x. Now if I do, of course, I want you to realize this is one giant fraction. You with me? Whatever I multiply the top by, I've got to multiply the bottom, same thing. Right? So anytime somebody asks me, why would you multiply 6? You just need a 3. I'm not allowed to. I need to multiply by 6, so I got to multiply by 6 top and bottom. I can't pick and choose. Cool? We all know that. Things get weird when you start throwing x's and stuff in there. But it's the same exact rules. Now, one little thing you make this do is make this easier is I got to distribute so you can write it next to each piece. Now you just start simplifying. Like here, what happens? Cancels. Now, do these x's cancel?
No.
Why not? They're across from each other, right? This is over 1 if you want. So this will be x times x. What happens on this one? X is canceled. 3 times 6? 18. What happens on this one? Yeah, you get a 2. So 2x times 1 is 2x. And here the x is canceled.
Plus 3.
Plus 6. Right, because nothing cancels that 6 dude yet. Now can you factor the top?
No.
No. Not nicely. You actually could factor it, but it would be x plus square root of 18, x minus square root of 8. I don't want to deal with that. That's crap. Why wouldn't I? I just did. There's no way to go back. So, since you said that, how do you factor this?
X plus 2x.
Yeah, why is it 2 and minus 2? Because the square root of 4 is 2. Right? So any number that's going to go there must be the square root of what was there, because the square root cuts things in half. And that's how you do difference of squares. Don't roll your eyes at me. I feel like I'm a father. So if I have x squared minus 12, just kind of extend that. X minus square root of 12. X plus square root of 12. Do we like the square root of 12? Do we like that number? Why is it not a big freaking deal? Because I'm done. So who gives a shit? Square root of 12 showed up at the end of the problem. Awesome. Good. It's there. I don't care because I'm done. Right? All right, enough of that. I agree with you. But since you brought it up and since you said that, I had to keep going with it. Okay. What's up? Yeah, this is it. Cool. Can't really factor that so that something's common with the bottom. The bottom would have, if you took a 2 out, it'd be x plus 3. There's no way to make an x plus 3 show up here. So there's no reason to go further.
I think that's throwing me off on that list because when you say 6, I'm like, oh, there's already a 6 there. So, like, I think of multiplication and I'm thinking, oh, I'm going to times 6 by 6. It just throws me off. I don't know why. On the top part, because you're trying to find the greatest or lowest, greatest common factor.
LCD.
Yeah, so here's an interesting way to find an LCD. So let's say I had 2 over, what you got, Jeff? 125x squared plus 4 over 50xy minus 2 over 10x cubed y squared. Okay, so if I want to get alright, no more of that question, right? Everything I do is an attempt to help you. That's why. So what do I do here when I want to try to figure out the LCD? I kind of break everything up. 125, does anybody know what that is? If you break it all the way up?
25.
Yeah, it's 3 5s, right? We have to know that for like cubes. So this is 5 times 5 times 5. This is a couple of x's, right? This is 5 times 5 times 2. X, y. And this is 5 times 2 with x, 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 y, y. So when I go to build the LCD, here's a really cool way to look at it. This is kind of different from what I was talking about before, because this isn't like little x minus 3, x plus 2. Those are kind of easier in a weird way. This is a little harder in a strange way. So when I go to build the LCD must have 3 5s. I can pick anybody to start with. It's got to have all these bottoms in it, but they can overlap. What do I mean? If this guy needs 3 5s, he needs 2. I already got 2 5s. I got 3 of them. He needs 1. All right, I already got 1 5. I got 3 of them. So I don't need 3, 4, 5, 6 5s. I just need 5, 5, 5. Sounds like it's a movie. I need X times X. Now look at the next dude. What's the new information he says? I need 2 5s. Got it. I need an X. I got it. I need a Y. Bam, that's new.
But
Right?
then you need another X.
Yeah.
Why?
Because there's 3 in the line.
I'm not there yet.
Oh, okay.
Yeah, so I looked at him. Now I moved to him. The new information he gave me was a 2. Did I write the 2 down? Not yet. So the 2 and the Y was the new stuff from him, right? And then I moved to the next guy. I need a 5 and a 2. Got it. I need 3 X's. Do I have 3 X's? No. Shit. Let me give myself another X. Do I have 2 Y's? No. Give myself another. That's the LCD. Whatever that is. So what is that? 125 times 2 is 250 by X cubed Y squared. That would have that in it. That has that whole thing in it, right?
Yes.
It's got a 10 and X cubed Y squared. It's got 50XY in it. Definitely it's got 125X squared in it. That's the idea of the LCD. You have to be able to find every bottom in it. That's why it makes sense to multiply by it, because it's going to kill every bottom. Some of them it overkills. But that's what you want to make sure that they're all dead, right? So it's like you get a big enough bomb to kill everybody. Right? So math can be so violent.
Can you multiply?
5 times 5 times 5 to the 2.
Okay.
There's a 2 there.
But that's a decent way to kind of build an LCD. Start with any bottom. It needs that entire bottom. Move to the next guy. What do you need? I got 2 5s. I got an X. I got a Y. Oh, I need a 2. Right? Oh, I need a Y for him. And then move to the next guy. What do you need that I don't have yet? Let me give it. That's another way to kind of build your LCD. Okay, good. You're good. Maybe. Okay. So let's do another one of these.
What chapter was that?
What's that? This is
Those are 7.4.
yeah. 7.3. There's a couple that are not quite that bad, but they're in that direction. Okay.
No, but the LCD is going to be 7.3.
All right. So let's see if they got anything freakier. Well, it's not too freaky. Oh, if it, well, all right. They got a couple of these problems that, if you get one that looks like this is number 13. So it looks like this. Look at this. 3A. (2a minus 5 over 3a over a minus 7 over 6a. All right. So this is nice. This is like the other problem, but somebody's already like combined the top and bottom. So either way you want to do it, it's going to be easier. So you can flip this dude and multiply and reduce. Or you can just multiply top and bottom by 6a. Cool. He's got this class after me, so he's always got to put his stuff there. Yes, sir. So which way you want to do it? I kind of prefer multiplying top and bottom because I don't have to rewrite it then, right? For one thing, because I'm lazy. So 6a. Those die. And what happens here? This goes into this twice. So then I get twice this. So what goes on the top? 4a. Minus 10. A minus 7. So appreciate it when it's given to you like that. That's going to be much easier. Right? Good. So what about, so that's one little thing. I want to show you the easier problem so you can identify it. Don't try to do too much with it. And then what about this here? This is not. not long enough for you. How do you make your A's? Your A's like that, and your 9's like that. Okay. All right. So this one, I don't know if this would freak you out or not. It just looks different. But how many fractions are inside? What's the only bottoms I have to worry about?
T.
Yeah.
That's all that's.
So what do I multiply top and bottom by?
T.
T. Cool. Now let me help the book out a little bit. Let me help the book out a little bit. Make that 4 a 3. No, don't worry about that. I'll do that later. Leave that 4 alone. So what do you got on top?
T squared minus 1.
T squared.
Yeah, T squared minus 9. Because here the T's would cancel.
And T squared
T squared
plus 4.
plus 4. Now you can factor the top, can you factor the bottom?
No.
So there's no point in factoring the top because nothing's going to cancel. Right, so I know I'm done. Cool, I like it. But, some of these could have a step where after you do this, you can do something that would cancel here. You have to do that. You have to keep going. Okay. All right. So last thing we're doing. Oh, holy crap. Last thing we're doing is me saying that. That sucks. All right, so next time we'll get into 7-6.
I have a question because we're turning my 10.3, my 11.1 and 11.2, but I haven't.
Okay. I haven't had time to grade anything.
Okay.
This weekend is going to be catch-up time.
Okay.
Yeah.
Could I go to the office now or you can't?
Yeah.
Okay.